And the next thing is data compression. What is this data compression? In the earlier PPT, in the earlier session, we discussed about data cropping, reduction, dimensionality reduction. How exactly dimensionality reduction was done? We removed unnecessary details. We removed unnecessary features. We cropped the data. And now the data set is ready. The data set should be stored somewhere before it gets fed to our machine learning model. For that, what we need to do is, we need to compress the data. Why we require to compress the data? See, we already have a data set that actually has been cropped. No more cropping can be done because all the necessary essential details are preserved. But still, it is taking more space in the memory. Is there any way that we can reduce the size of this? Yes, we can reduce the size by using something called a compression, data compression. In the data compression, we are going to compress the data without removing any more features whatsoever. In data compression, the data, if it is 4 GB, it will get reduced, but none of the columns will get removed. We are going to apply some methods to reduce the size of this data set. So, to store the data using fewer bits, because all that we have some memory, right? Maybe in our local system or in a cluster, we do have a limited amount of memory that should be practically and potentially utilized, that should be productively utilized. For that, data compression is inevitable. So, to store the data using fewer bits, which conserve the storage space and speeds the data processing. How the data compression is going to be done? The technique is lossless compression and lossy compression. What is lossless compression? For instance, I collected the images. Here, I do not want to reduce the quality of the images, but still, I want to reduce the size. For that, I can go for the lossless compression. I have a 1 GB image. When I reduce the size, obviously, we expect that image to reduce the quality, right? But there is something called a lossless compression. The lossless compression, the size will get reduced, but the quality will not get reduced. That is called lossless compression. There are some techniques which is called run length encoding, RLE. By using RLE, we'll be able to go for lossless compression. We'll be able to reduce the size of a data or a data set, or entire data set, without affecting the quality. And similarly, there is something called LZW, Lempel-Ziv-Welk. These techniques are used for lossless compression. There is another something called lossy compression. In the lossy compression, of course, the data quality will get affected. But even sometimes we don't even mind, even if the quality gets affected, because we just want some important information. If the quality gets affected, if you don't mind, even if the quality gets affected, if we don't mind, we just don't go for the lossy compression. The lossy compression, the data is lost, typically used when extract reproduction of the data is unnecessary. Exact reproduction is not needed. I don't want a complete picture in the same resolution. There's a dog. Dog feature should be retained. I do not want an extraordinary detailed dog. I just want some dog face to appear right after resizing, right after compressing in an image. So what I do is I just go for lossy compression. Techniques include JPEG, image compression, your JPEG file itself, it is better to, when you convert any file, any picture into JPEG, obviously it will get reduced, size will get reduced. At the same time, you also can spot some loss in the data. Okay, and MP3, audio compression. Generally, when you record an audio, it will be in the WAV format. The WAV format will be converted to MP3. During this conversion, there will be some loss. It is not insignificant. It is insignificant because during the conversion, you don't get to spot any differences. But still, there is some loss. Okay, application storing the large data set in a compressed format, streaming and transferring the data over the networks. Now you just streaming the videos in your YouTube channel. Would you be able to stream a 4 GB video? No. Would you be able to store a 4 GB video? Because it is highly irrelevant, right? We just, whenever we stream the data should be reduced in size. YouTube is a wonderful example for this. Why data reduction is important? In the data reduction, we have two separate wings. First one is data reduction itself. Second one is compression. In the data reduction, in the actual data reduction, we are removing some unnecessary details. In the data compression, after removing the unnecessary details, we are reducing the size. Okay, and efficiency. reduces the time and the computational power. Obviously, more the data set, more the time, more the computational power, and more the resources, right? Obviously, when you reduce, all these factors will get optimized. Then the scalability. You will be able to scale to any level. You will be able to scale this data set to any algorithm. Some algorithms doesn't work better on huge data sets. So in order to scale, data reduction and data compression are inevitable. Improved model performance, obviously model performance will be better when you reduce the data set size and compress it. And storage savings, obviously this is one of the key feature you actually knew. How vital is storage? Because all that it requires is RAM. There are two parameters in storage. One is RAM, one more is our hard disk. Hard disk is one important thing that we need to conserve. Right after which RAM is another important feature, because when the image is being processed, let us understand, you're watching a 4K video. 4K video, let us say take 12 GB. 12 GB will get stored in your hard disk. Right then, when you execute it, when you're watching that 4K video, it will get transferred to RAM. So RAM is very limited amount, right? RAM is around 2 GB to 4 GB or max 16 GB. If the size of the file is more, obviously your performance will be better, because you will be able to observe the lags in the streaming. Similarly, when the model is performing and RAM size is slow and your data set size is bigger, obviously you can observe some computational lag. So this storage savings will be a vital, and will get better as you compress and reduce the size of the data.